Okay, here's number 4 from sum review number 7. These problems are kind of long, so apologize for that. Okay, so let's see what we've got here. So this was the function was f of x equals 2 over x squared, and I can factor the bottom. Now when I look at this, what do I like about this? Well, it looks like it's an even function. In other words, if I put negative x in here, f of negative x, because this is f of x, f of negative x, well, what's a negative x squared? Just x squared. So it would look exactly the same. So we would say f of negative x equals f of x. So it's an even function. That means it's going to be symmetrical about the y-axis. So I just have to graph half of it, and then the other half is just reflected. So that's going to make my life a lot easier. Okay, so let's check some intersection points. First of all, let's see what happens when x is 0. So I put 0 in here. And 0 minus 1 is negative 1, so I got 2 over negative 1, so I got negative 2. So I know the point 0, negative 2 is on my graph, so I'll put that right there. Okay, and I know the degree of the top is definitely smaller than the degree of the bottom, so I have a horizontal asymptote at y equals 0. It's an automatic. And then I've got vertical asymptotes at anything that makes the denominator 0, so that's going to be, I'm sorry, vertical asymptotes, I said that. And that's going to be x equals negative 1 and x equals 1. So I'll draw those asymptotes in. So my vertical asymptote is at y equals 0. Now that should be a dashed line. It's kind of hard because it's right on the axis here. So I know I've been putting solid lines in here, excuse me, so I should put some dashed lines there. And then the vertical asymptote is x equals negative 1. And x equals 1. Okay, so there we go, we got that. So let's check, see what happens at the asymptotes. It's going to look like this or like this, and there's all kinds of possibilities inside here. It could look like this or like that. Okay, so let's try it as x approaches negative 1 from the negative direction. So that means I'm approaching negative 1 from the left. Okay, so if I look at this, now this is going to be a problem. I can't put a negative 1 in here, so I'll have to write x plus 1. Because if I put a negative 1, I get a 0. But this is okay here. I could put a negative 1 in here, and I have negative 1. Negative 1 is negative 2. So y equals, and then a negative 2 under a 2 is just negative 1. So I end up with negative 1. All over x plus 1. Okay, we'll leave it like that, okay? And now we can use a small approach. Now, I'm going to be just to the left of negative 1, so that might be a little bit bigger, so negative 1.0001. So it's going to get even more zeros, as many zeros as you want, as close as you want to get to negative 1 from the left. And then that's going to be plus 1. And that's going to be the same as negative 1 over, and that's going to be negative, because this is bigger than that, the absolute value, so that's going to be negative and a very small number. Okay, it's even, it's going to be smaller. Now, as this gets, so what's a negative over a negative? It's a positive. I think we can see that. I'm trying to save a little space here. And I divide 1 by a very, very, very small number, I get a very, very big number, or infinity. So I get positive infinity. I hope you can see that okay. All right? So that means as I approach it from the left, I'm going to get positive infinity. So it looks like it's going to be like this. And you could put more points in here, some key points at like negative 2, see how close it gets. You know, you could do that, but we're just getting a kind of a general sketch based upon the asymptotes. That's just what you want to do. It's called curve sketching, not curve graphing. Okay, Now let's see what happens over here. Am I going to go like this? Am I going to go like that? Am I going to go like this, like that, or like that? So let's see as y approaches -1 from the positive direction, or as x approaches, excuse me. So x approaches -1 from the right. And again, we can use this form over here. So that's going to be -1 all over x plus 1. And that's going to be -1 all over. And if I'm to the right of -1, I might be at 0.9999. That's just the right of negative. And then over here we're plus 1. So that's going to be -1 all over it. Now what's bigger? Well, 1 is bigger than that, so it's going to be positive. That's going to be 0.0001. Or smaller. So that's going to be positive, negative or positive is a negative. And 1 divided by a very, very, very small number is a very large number, or infinity. So I'm going to have negative infinity. So it looks like I'm going to go like this. And I'm going to go through this. Now, pretty much done because it's an even function, so I just reflect it, so the other side's going to go right back around. It's got to look like that because it's symmetrical to the y-axis. So that's got to go down like that, and this has got to look like that. Because we have that nice even function, that saved us a lot of work. We would have to check them right around 1. Okay, so let's see what that looks like. I didn't graph this one ahead of time, so I have to graph it right now. Hopefully you got your equation there. So turn this guy on. And let's see here. Oh, I got to clear that. Well, actually we had 2 divided by, and was just x squared. So I can delete that. Delete that and make that a 1. So there's your equation. 2 over x squared minus 1. There we have our window set up, so let's graph that, and there you go. Looks pretty close, doesn't it? And if you wanted to see that horizontal asymptote of -2, well, I'm sorry, there was a horizontal asymptote of 0. That means it just goes through -2. Pardon me. That's the intersection point right there. 0, -2. Excuse me. All right, so there's your graph. No problem. Pretty easy.